Right guys, so today we're going to be doing a G modular harness. So it's for a 1G-FE VVT-i and it's going into an IS200. So let's get into it. Right, so as I said, this is going to be a G modular harness, so it's for a 1G-FE VVT-i going into an IS200. Customer is going to be running a turbo application and he's taken a whole bunch of goodies, so there's a lot to go through today. But first of all, let's take a look at the build process we usually do so you can see exactly what goes into making one of these, and then we'll show you all of the sub harnesses that we have built for this particular setup. Right, so there you go. You can see everything that we built for this harness to be set up. And as you can see, it is quite an extensive harness. We've added quite a few things and done quite a few customizations for it. Now, I know it says it is a G modular harness, so it's designed for the G series of engines like 1G. To be fair, this would actually also work on a JZ as well. So if the customer ever changed their mind and wanted to use it on a 2JZ GE or a 2JZ GT VVT-i, or even a 1JZ GTE VVT-i, there would be absolutely no problems at all in doing that. Everything in this harness is compatible with a JZ as well. Okay, now as you've seen by the photos, there is quite a lot going on. We have cooling fans over there, we've got a Haltech Dash over there, we've got CAN Keypad buttons over there. Okay, so there's a lot going on. Now, I know this is going into an IS200, but you can clearly see this is not a plug-and-play version of that, aka we're not going to be plugging it directly into the ECU box that lives behind the left-hand engine light. Okay, so everything is going to be going inside the vehicle, and that's where it's going to be living. Right, so as all of our harnesses, the first thing we're going to do is we're going to go through the entire layout of the harness, showing the customer exactly where everything goes, where everything plugs into, and what expandability they will obviously have further down the line if they decide to do so. Then we're going to do the testing, which is made up of testing with just the ignition on and with the engine itself actually running. As you can imagine, I can't run it in this particular stage. Obviously, I am using my 2JZ GE VVT-i to do all the testing on this. The 1G and the 2JZ GE VVT-i have exactly the same crank sensors. The 36-2, they have exactly the same cam sensors, which is the 3 teeth for the VVT-i. So basically, the only difference between this and a 1G is the fact that this is 3 liter as opposed to 2 liter. Okay. So perfectly fine to use this as a test example. So let's go through the layout and let's start here on the bench, because there's actually quite a lot to go through on the bench here, and then we'll make our way to the engine harness. So starting with the ECU over here, nice and simple, 2 plugs over there, nothing complicated. There's the new cable that ECUmaster have been releasing with the black. This allows you to leave this cable in the car with the ECU, so you're not taking a USB cable in and out of the more sensitive port that lives on the actual ECU itself there. So that's a nice new feature that they have added on, okay? Then we also have the wires coming off there, and that goes to this side of the fuse box over there. So that is from the engine harness itself. Then we have that fuse plug, which goes around and comes in that side over there. So that's a lot of the signals that are coming from the ECU to the fuse box to power certain things, okay? Moving along over here, you'll see then we have 3 breakout harness sections over here. This one is an expansion one, and you can actually see I've got a pin out there of what's involved or what's pinned into this expansion plug over here. We then have a pedal plug because the customer is using drive-by-wire, so we've included a pedal plug there. This is also his pedal that's going to go off with him as well, and that's what he'll be using inside the car. Then we have our communication port. So this is to have the CAN bus and the RS-232 communication. Now in this particular case, we're not using the RS-232, but it is available if he decides to use it. But this COM cable over here is going into a harness that breaks off there, breaks off over there, and then it ends up at the CAN buttons or CAN keypad. It then breaks off to the ECUmaster USB to CAN, so you can interface with the buttons and everything via that particular setup over there. And if he decides to expand to any other ECUmaster products, you usually have to have a USB to CAN to talk to things like the PMUs and all that type of stuff if you wanted to upgrade further down the line. Then we have our cable that runs all the way along there, and that is then going to be going to our Haltech IC7 Dash, and that is connected via CAN bus to the ECU. There will be a few connections that he has to make inside the vehicle, things like indicators and headlights and high beams and all stuff like that, but we'll go through that with him when the time comes. All right, you'll see it's got its own fuse box. This is a completely standalone unit. It can actually be used in any vehicle. So despite the fact that it is going into an IS200, if the customer ever changed their mind and wanted to put either their engine or use a 2JZ in another vehicle altogether, this whole setup can be transferred to that. So really, really nice functionality there. Okay. Coming back to the fuse box now, you'll see we have our obligatory 9-pin plug. Okay, same on every single harness. In this case, some of the stuff is not going to be used. Obviously, we're not going to be using the temp because we have the Haltech Dash. So when we go through the coolant sub-harness, you'll see I'll explain there in more detail. Also, we're not going to be using the start wire because in this case, we can actually use the CAN keypad. That's going to become the starter now. So that is a nice feature there as well. Moving over here is a 6-pin plug that we don't normally have on our aftermarket harnesses, and this is for the fan control. So what you'll see here is if you follow this along, we've got a really nice long cable here, which runs along there and plugs directly into the cooling fans, okay? And coming out of that plug as well, after a short distance, you'll see we then have our ground point for the fans. So the customer's going to be grounding the fans kind of in the engine bay as close to the fans as is humanly possible. Now, obviously, we've taken care of all the wiring on the fans. We've put clips in to keep it all nice and neat over here as well. They are completely unpluggable, each individual fan. So if you ever need to replace the fans, you can unplug each fan individually, replace it, and put a new one in, and off you go again. We've also put a connector in here so that this whole shroud along with the radiator could be removed from the vehicle by simply unplugging one connector, and it'll all come off together. Okay. Right, so that's everything on the engine, or should I say more like the interior side. I know that's cooling fan and that does come through into the engine bay and around the front, but because it's attached to the fuse box, I've just included that all in there for you guys. Right, so moving along, going along from there, we then have the grommet, which you'll obviously be installing in the firewall. As per usual, we haven't shrunk the SCL down. He's going to be able to move this grommet around, up and down this harness to see where the best fitting place is going to be. Moving up along there, we then have our first breakout over there, and there's 3 sections that pop out over here. We have our injector sub-harness, we have our ignition sub-harness, and we have our wideband oxygen sensor harness on there as well. This is pinned straight to go into a Bosch LSU 4.9. So again, if you don't use it, to just sort of tuck it away. If you are using it, a Bosch LSU 4.9 will plug directly in, as you can see I have just over there for testing purposes. All right. Moving along over here, so again, like I said, injector. In this case, he is running what we call USCAR injectors or EV614 injectors. So obviously I'm making adapters to my normal Denso injectors. And in terms of coils, he will be running Audi R8 coils, these red ones. Not these specific ones, these are mine for testing purposes, but that is the coils that he will be running in this particular case. Okay, and they're on sub harnesses, so they can be changed at any time. So for whatever reason, things change, they need to make a change, no problem at all. We can just phone us up and we can make him little sub harnesses that'll do that change for him. All right, moving up along there, and we end up at the next breakout, which is going to be here by the cam sensor. So on his 1G is pretty much in exactly the same place, so that's all fine. Also coming out here is 2 earthing points over there. We made them quite long, so you can hopefully find a grounding point there, sort of similar to what we have over here. Just any bolt that goes in the inlet manifold will be a good enough ground for that particular setup. Then moving along from there, and then we have our big breakout section over there, which is then going to go underneath the throttle body or inlet manifold. I think he's changing his inlet manifold to a front-facing one. Anyway, moving down over here, let's pop down. And if you've seen our JZ modular harnesses, a lot of this is going to be very familiar to you over there. So we'll start with the sort of thin-ish wire over there. And again, as per usual, that is our starter motor over there. Remember, guys, you need to connect your starter motor directly to your battery. This is the main power cable. All right, so that is going to be separate. That's not part of the engine harness there. Okay. Next up, in this case, we'll go to the back over here, and then we have our knock sensor. So in this case, the customer has opted for the Bosch wideband knock sensor. So we will be supplying him both sensors, both studs, and both bolts to bolt those directly to his block, which will be over there and over there. Okay. Next up is our fuel plug. So in this case, we didn't have the ability to put fuel temperature as well because he's definitely running drive-by-wire, so no problem at all. So in this case, we just got a 3-pin plug that he could connect a fuel pressure sensor to. We just can't do fuel temperature in this particular case, okay? Next up is going to be his throttle plug over here. So it's our usual modular 12-pin plug. So this one is perfectly capable of running a Bosch drive-by-wire, which is exactly what he's going to be running in his case. We also have the intake air temperature sensor built into this one as well, so that's going to plug into there, and that's the IAT, so we can mount that into his intake pipe at the front there before it goes in. Okay, this plug is also perfectly capable of running a 2JZ GE VVT-i drive-by-wire throttle setup, 2JZ GTE VVT-i drive-by-wire, as well as the 1JZ GTE VVT-i throttle setup. Okay, it's got everything in there that you need to run all different types. So with those earlier clutch style ones that have the built-in accelerator position sensor, obviously you just wouldn't use that pedal plug, or you could use the pedal plug and you didn't have to plug in the pedal position sensor on the actual throttle itself. You have a choice there in that regard. All right, let's go next up here, and you'll see we have oil. Okay, our normal 6-pin oil plug. So at the moment, we're just using the oil pressure switch that comes standard on the 1G and 2J and JZ engines. He does have the ability to obviously upgrade this. He can put both an oil pressure and a temperature sensor in. It's absolutely fine. There is the facility to do that. Okay, so that's everything that's coming out down here. Pop back up again, and obviously the harness gets a hell of a lot thinner now, moves up into here, and we're going to have a breakout section there. One of those is going to go over, and that's going to be to our oil control valve. So again, found on the 1G and the JZ engines, very similar there. And in this case over here, popping over to the back here is going to be our coolant temperature. Now, it is a 3-pin plug because remember we have put allocation to put your own single wire sensor in if you needed to. And that's why we still have the normal 9-pin plug. So the yellow-green one in this case is not going to be used, but it is there if he does want to use it, or if he even passes the harness on to somebody else and doesn't sell the complete package. Obviously, they can add it and change it later. So that's going to come down, and it's going to go to the plug which is suitable for the 1G-FE temperature, which again is under the thing. It's sort of same situation as the 2JZ G VVT-i on this side of the engine. So this will be plenty long enough to reach over to there and plug in. So that is super easy. So let's move along over here, and then we are going to pop down through here. And we're going to have another breakout just past the cylinder head over there. And it's going to break out into 3 sections. Oh, hang on. I did miss one. I do apologize. Back over here, there is actually 3 sections coming out. This is one of the new things we did for the G harness, because obviously the alternator on a 1G is on this side. The alternator on a JZ is on this side. So in this case, what we've done is we've made an alternator on a sub harness, and we've broken it out at the top over here. Now in this case, you can see I have plugged it into our JZ harness here. And again, this is why I said I made a change, but I made it work for both. So in other words, in his particular vehicle, he's going to take that, but that's actually going to now come over this side along with the coolant one and actually be plugged in on this side over here. But again, if you have had a JZ, as you can clearly see, he would just bring it over to this side over here and then plug into a JZ alternator over there. So I've still kept it to work for both, just to be on the safe side there. Okay, so moving down to here, this breakout is only going to be 2 sections. Used to be 3 because the alternator used to come out here on the JZ harnesses. But anyway, so the first one is going to go to the crank sensor, which plugs directly in there. Again, same setup as the G and the JZ. And then second of all, we've got his Mac boost valve. So again, straight over there, so you're going to be able to control the boost electronically via the ECU itself. Okay. Right, so now that we've done that, let's go through the plugs that he's got on his side and what he needs to put in on his side over there. So what we'll do is we'll start with the 9-pin plug, because that's really kind of the only thing that he's going to need to connect apart from 2 wires and that 6-pin plug over there. Okay, again, if you've watched any of our other videos, this is going to be like a hell of a repeat for you guys. There are some slight differences between a standard management system and this one over here, but let's go. Number 1 is going to be red. So again, it's our red thick 14 gauge wire. I left it as permanent 12 volts because you can connect permanent 12 volts. Absolutely no problem with that whatsoever. But in this case, it doesn't need to actually be connected to permanent 12 volts because it is an aftermarket ECU. But I do leave that instruction in there anyway. But in this case, you can actually connect it to an ignition 12 volt source. It's not going to make all that much of a difference, okay? But what you mustn't connect it to is an accessory source if you are using a key barrel. Next up is going to be black with a yellow, which is normally our start signal. In this case, we aren't using that as the start signal. The keypad's going to be our starter button, but this is a caveat. Just in case, like I said, he sells the setup, but not the complete setup. Let's say he wants to keep the dash and the buttons and all of that type of jazz, but he wants to do on something else. Then what I have done is that black with the yellow wire is actually going to the ECU and can be used as a starter input, okay? So it's not saying that only the CAN button cans. He's quite happy to provide either 12 volts or ground to that black with a yellow wire and just change the settings in the ECU, and that will act as a starter. But in this case, the ECU is controlling the starter relay. Okay, so once you press the button, you'll see we do the testing, it takes over and it's going to start the engine. So you don't have to worry about that. You just do one press of the CAN keypad, boom, ECU takes over and starts up the engine. Right. Number 3 is going to be yellow with a green. That's your gauge temp. Again, that wire comes to this 3-pin coolant temperature. Again, in this case, because he's opted for the Haltech IC7 Dash, we don't need to connect a single wire temp sensor because you don't need to have any sort of interface other than the Haltech Dash, and that's going to give him his coolant temperature there. But again, it's still there because it's all standardized, and if you ever wanted to set it on, someone else could use it, okay? Then it's going to be number 4, which is gray, which is obviously unplugged for the moment here, but that is going to be his fuel pump. So again, that is hooked up currently to my fuel pump over here, obviously as part of the testing over there. But you can run that gray wire straight to your fuel pump. No dramas at all. It is relayed, it is fused via the fuse box, so no worries with running it straight to the positive side of your fuel pump there. Next up is going to be number 5, which is going to be yellow and red, which is going to be a check engine light. Now, again, we do still have the LED inside the fuse box. That's completely standard for us. So again, that does act as a check engine light. But obviously, with the Haltech IC7 Dash, a check engine light is going to be transmitted via CAN. So he doesn't need to connect that at all, okay? In his case, no need for that. It's all going to work via CAN via his dash. Next up is going to be yellow, which is going to be tacho signal, and it's going to be a repeat of the check engine light. Yes, we have it in there. Yes, it is an output from the ECU to give out a tacho signal, but he's not going to be using that because he's got the Haltech Dash, and engine RPM is going to be transmitted via CAN to that for him, which again, we'll show you in the testing there. Number 7 is going to be black with a red, and that is going to be ignition power. Now, that is one that he's going to be using finally, and that is how he's going to be powering up his system. So that is going to be provided with 12 volts and ignition 12 volts. So as per usual, if you are using a key barrel to do this, make sure you have an ignition 12 volts, not an accessory 12 volts. An accessory 12 volts is the one that cuts out when you move the key from the ignition to the start position, okay? It's the same reason your radio cuts out when you go to start your car. That's the feed, the accessory feed. So if you are using a key barrel, please make sure that you double check with your multimeter that if you find a 12 volts at the back of the key barrel, if you turn it to the start position and that 12 volts then disappears, Forget that wire, that's an accessory feed, use it to power radio or whatever. Find the ignition 12 volts that stays on when the engine is cranking, okay, or the key is in the start position. All right. Right, next up is going to be 8. It's going to be pink and blue, and that's going to be the charge light. So again, that is connected to the alternator. And again, in this case, to be perfectly honest with you, he's going to be able to see battery voltage on his dash, and he can create an alternator light via that. So again, that is not necessary, but by all means, he could connect that to the dash as an input and call that the charge light or whatever if you wanted to as well. Totally open to him. Next up is going to be 9 with a yellow with a black, and that is going to be oil pressure. So again, that is just the oil pressure switch that is standard on all of these engines. And again, he doesn't really need to use it, but because he's not running oil pressure, I'd probably advise that he takes that oil wire and he feeds it as an input to his dash for now. And then if he upgrades to an oil pressure switch later on, obviously then that's no longer relevant, because then he'll be able to see oil pressure on his dash. Okay, so for the time being, without having oil pressure, I would advise connecting the oil pressure lights to the dash just to give you that light on and so on. And you can connect obviously the charge light as well. All right, unless you just want to use the voltage like we have over there, showing battery voltage over there. Okay, right, so that is the 9-pin plug. Super easy, super common. If you've seen it already, you've seen it a million times now. Again, it's a pretty standardized plug that we put on there. Next up is the 6-pin plug. Now you'll see there's only actually 2 wires to connect on here. Is 2 red wires, and I've got 1 still in there, and I've got 1 running to the positive of our battery over there. That is the power for the fans. Now in this case, what I did is I kept it separate from the rest of the system. So I've given you 2 14 gauge red wires that you can run to a permanent 12 volt battery source or an ignition 12 volt source, whichever one you want. It doesn't really matter. It's basically the power for the fans themselves. Okay. Now, the acute amongst you would have noticed I've actually created a bus bar with the fuses over here. So it's these 2 fuses over there. So effectively, you could connect 1 or both of them. I've just given you that as a bit of overkill, so you can take both of them, join them together, and run them to a sufficient 12 volt source over there. Now, if anybody's interested, these fans actually only drill a maximum of about 13 amps. And then that's just on inrush current. And then once they are running, they are drawing about 7 amps. Okay. So in actual fact, they are not drawing a lot at all. It's the inrush current that causes you an issue over there. Okay. Right. So that is the 6-pin plug. It's basically 2 powers, super easy. On your expansion plug, which is this one over here. Okay. Again, we're not going to supply him with anything unless he needs it. He can give us a call and we'll make him whatever harness to plug in there. But we have a flex fuel sensor input. We have switch 1, 2, and 3. Now, as you can imagine, he's got a CAN keypad. He's got a whole bunch of switches over there. At the moment, I've just allocated engine start, engine stop, fan 1, and fan 2 on there. And then the 2 are open at the bottom, so they can be used for table switching. They can be used for, you have 2 throttle pedal maps on this one. So one could be, say, snow, and the other one could be like a map switch for higher and lower boost or anti-lag or whatever you wanted, basically, in that regard. Okay. But that's that. So those are your 3 switches that are going in there. So if he needs to add more switches in, he's got 3 that are open to him there. And then lastly is the vehicle speed sensor. So again, nice and simple. If he ends up having a gearbox with a speed signal, he can connect it to that. But in all honesty, you're probably best off just going with the GPS and plugging it into the Haltech Dash and then transmitting the speed over to there. Okay, but both options are open to you. Don't want to limit him to that. And then lastly, I've just given the pinout of the communication cable, which is basically pin 1 is CAN high, pin 2 is CAN low. Then you've got 12 volts and ground. So we have provided everything in here to run CAN-based devices. So all the power for the dash and the buttons is coming from our fuse box. There is a dedicated fuse called CAN 12 volts that obviously is supplying everything on the CAN bus over here. Okay, and then in this case, obviously RS232, both receive and transmit are not connected because we're not using any type of EDL logger or something like that that can use that particular data. All right, again, can be added on in the future, not impossible to add it on later. All right, so that is the layout of everything. So hopefully that's nice and simple and straightforward. Again, it's our modular design. If you've seen our videos in the last year, you'll know exactly how this works. We create basically a Lego system that you guys can effectively chop and change as you like. We can just build you the small little harness sections over there. We try and cover as many sensors as we think is applicable to most applications. So oil temp, oil pressure, fuel temp where we can, but I always make that a luxury because it's not a very common one. We always put in the ability to have a Mach boost valve, even if you don't take it. We always have the ability to put in a wideband sensor, even if you don't particularly use it. But we always do have that built in for you. So if you do want to upgrade, just give us a shout, and in this case, just order a wideband sensor if you wanted to plug that in. If you wanted to change your injectors, just phone us up. We'll make you a little sub harness and you can unplug your old one, plug in your new one. So the idea is, once you've bought this harness, unless something drastically changes, you should be good through your entire upgrade process and be able to swap everything out as and when you need to. Okay, but that is the layout. I'm gonna shoot off now. We're gonna come back and we're gonna do the testing. So, see you in a second. Right guys, so we are back for the engine testing portion of the video now, and again, as usual, it's going to be made up of two sections, one with the ignition on and one with the engine running. You'll see I've put an inlet manifold and a throttle body on there so we can actually get the engine running now. Obviously, I've had to remove the Audi coils because they don't fit under this particular throttle over here, so I'm just using the dumb coils that come standard on a 2G VVT-i. You'll see that I've also removed the throttle plug because I've put my own harness on. And as I said, we've wired in the harness as standard the ability to run these ETCSI throttles that you find on so many Toyotas. So this harness can run those as well as a Bosch drive-by-wire throttle, as well as no drive-by-wire throttle. Okay, now, first thing we're going to do is going to go through all the tests that we are going to do, and just a caveat, it might seem small and it is small. What we do behind the scenes is hours of testing to make sure that everything works 100%. We test all the inputs, we test all the outputs, we test absolutely everything that could possibly be connected to the harness, and that would be a very long video to make. I don't want to bore you guys to death, so down below in the description there'll be a link to the ECUMaster playlist. On there I've done loads of little videos explaining particular small sections in detail. Always open to suggestions. If there's something on there that you guys would like to see that you haven't seen yet, let me know. And next time we have an ECUMaster product, we will then get a video done for you guys to explain something in greater detail. Okay, right, so let's get back to what we're going to be testing on today. So first of all, we're going to be doing the check engine light. So all I'm basically going to do is make sure that the LED comes on the dash over there. I'm going to make, and the fuse box over there, I'm going to make sure that the check engine light comes on the dash. Remember, that's being transmitted via CAN from the ECU. And also what I'm going to do is I'm going to put my little wire here, which is connected to switch 1 on the expansion plug. I'm going to put it into the yellow with the red wire over there, and I'm going to use the ability from the switch. So you'll see there it says 1, which is effectively on, but the ECU is not on at the moment. That's just an idle dash, if you will. And so basically what I'm looking for is when I put the wire in, it's going to go from 0 to 1, and I take it out, it's going to go back to 0 again. That tells me that it is grounded out. That tells me the check engine light is connected correctly. Next up is going to be oil pressure, and I'm going to do a similar thing. I'm going to take my wire, I'm going to stick it in the yellow with the black. Then I'm going to make sure that the 0 turns to a 1, which tells me that that yellow with the black wire is grounded. I'm then going to pop over here and I'm going to disconnect the oil pressure switch. And then you should see that 1 turn to a 0. That tells me that it is the correct wire that it's connected to. Next up is the alternator light, and again, it's going to be pretty much an exact carbon copy of the oil pressure light. I'm going to put the wire in there. I'm going to pop over there to the other side, unplug the alternator, look for the 1s and 0s on the dash, and I'll explain it as I go along. Next up is the Haltech Dash. So basically what I want to see is that it powers up, it connects, we're getting live data, and that live data should match. So we'll be able to go over here, see our coolant temp, our IAT, etc., and that should be replicated on the dash over there. When the engine's running, we'll obviously take a look at that as well, and you'll see that the RPM and everything is coming through there nicely. Next up is cooling fans. So what I'm going to be doing now is the way I've done the cooling fans, and it can be altered if you want, but where you have individually triggered each fan, and I'm using an output that has 2 conditions. One of them being the CAN button. So 2 of those buttons over there activate the 2 fans. So you can activate 1 fan or both fans at the same time. And on the actual software itself, what I've basically done is I've set up the fan that is closest to the inlet to come on at 95 and go off at 85, and I set up the fan that is closest to the outlet that goes back into the engine to 90 and off at 85. Okay, so in other words, only one fan will come on when it hits 90. If it hits 95, the second fan will come on, and then they will both only turn off when it drops to 85. Now, that's just something I've thrown together. Obviously, when it's in the vehicle, you're going to be better off seeing exactly how your engine performs, what the coolant temperatures are going to be, and then you can change that particular setting to suit your application. Again, you're on a standalone ECU, you can do whatever you want. no problems whatsoever. Right, so that's going to be the cooling fans. Next up is going to be the fuel pump. So as per usual, I'm just going to go into testing outputs and I'm going to test the fuel pump and you're going to see it flick on. But you will also hear the fuel pump prime when I put the ignition on as well, okay? That's going to be all we're testing with the ignition on. So I said it's quite a short one. But like I said, I've got videos down below of how to test things like your injectors and coils and all that type of jazz. So I'm not going to repeat that every time. In terms of the engine running, what we're going to do is we're going to test the starter circuit. So again, like I said, I've got basically that wire over there, the black with the yellow one in this case is not connected because we are using the CAN buttons to start the car. But like I said, that one still goes to the ECU. So if you wanted to remove the CAN buttons and still wanted to have a start signal, you can use that one over there and you can supply it with either a ground or a 12 volts. It's not a problem there at all. But for our purposes today, we're going to be using the buttons. We're going to press the start button on there. ECU is going to take over and it's going to keep cranking until the engine starts. So this is not something you've got to hold the button down. You just press it once and let go. ECU will take over and start the vehicle up. What I've also put down here is we're going to do a stop engine test. And that's basically because the other button that I have underneath the start button on the CAN button is an engine stop switch. So basically what I'm looking for is I'll press the button to start the engine up. I'll press the button underneath to stop the engine. You should hear the engine shut down. And then I'll press the start button to start it up again. So in this case, you don't need to turn off your key or anything to kill the engine. You can literally just press the button and it'll shut the engine down, okay? Again, these can all be changed inside the ECU. So if you need an extra button for something and that wasn't particularly important to you, you could remove that button from that particular function and change it over to something else. Next up is going to be the accelerator pedal. So what I'm going to basically do at the moment, that accelerator pedal is plugged into the harness. So I'm going to use that one to quickly give it a rev so you can see that it is actually working. Then what I'm going to do is I'm going to unplug that one and I'm going to plug this one in just to demonstrate for you guys that you can use either that throttle that has an accelerator sensor built into it, or you can use that one. The wires are going to both places over there. Okay. Then I've put down tacho and coolant temp. Well, basically all we're going to do is pop over to the Haltech Dash. We'll give the engine a quick rev. We'll see that all the RPMs and everything are coming through via CAN to that Haltech Dash. Okay. So without further ado, let's just go ahead then and quickly fire this thing up and put the ignition on. Okay, so I'm just going to put you down over here for now. I don't think you're going to see an awful lot, but oh, you can see what I'm busy with there. But here is my wire. Black with the red tracer, giving it 12 volts. And there you go. You can actually hear the fuel pump priming. That's again set up by the ECU. You can determine how long that prime sequence will go on for. So that's all with the ignition on. We're super happy with that. So let's move over to the first one, which is the check engine light. So you can see that I've got the LED on the fuse box. Happy with that. We've got the check engine light on the Haltech Dash. Super happy with that. So all I'm going to do now is I'm going to attach my wire here to the yellow with the red wire. Let's go on there. Hang on a second. Right, so I have attached my wire to the yellow with the red wire there. It says 1, and I'm going to pull it out, and it says 0. So that tells me that that wire is grounded out. So that is perfect and exactly what I wanted to see. Next up is going to be oil pressure. So again, all I'm going to do is I'm going to take this wire, I'm going to place it down in here, and you can see it saying 0. As soon as I put the wire in, it is saying 1. And what I'm going to do now is I'm going to disconnect the oil pressure switch, come back to here, and you see it says 0, and I'm going to plug the oil pressure switch back in again, and there it goes back to 1. So perfectly fine. That yellow with the black wire is connected to the oil pressure switch and is working as I expect it to. Next up, let's go to the alternator light. So all I'm going to do again is use my wire. We're going to plug it in over there. You'll see that the switch 1 is showing as 1, which means that pink with the blue wire has a ground, which is what I'm looking for. I'm going to pop over here and I'm going to disconnect the alternator plug. And you'll see that that 1 has gone back to a 0. I'm going to plug the alternator plug back in again, and it goes back to a 1. So that's absolutely perfect. That tells me that pink with the blue wire is connected to the alternator light wire on the alternator as it should be. Super happy with that. Next up is the Haltech Dash. And I'm going to try and get a good picture here. But yeah, you can see there 44 degrees coolant temp, 29 degrees air temp. And if we come over here, 44 degrees coolant temp, 29 degrees air temp, 12.5 voltage. And you can see 12.5 voltage there, okay? So Haltech Dash, absolutely fine. Everything's communicating as it should. Let's move on to the cooling fans now. So as I said, the cooling fans are designed to come on under two conditions, one being the actual coolant temperature, so they'll kick in when that happens as well. But obviously we have built in the ability to turn them on manually. So if you take a look over here, you'll see if I press this button, one of the cooling fans turns on. I don't know if you'll see, but it's definitely that one over there. Switch that off. We'll switch that one on. And you can see that that one is now spinning and that one has come to a stop. We'll flick that off over there. Okay, so that's the cooling fans done. Super happy with that. Now we're going to test the fuel pump on here. So what I'm going to do is I'm going to go over, I'm going to see if I can get you guys in a good position over there. I'm going to go over to tools, test outputs. Now I know that auxiliary 1 is my fuel pump. I am going to cycle on for 500 seconds. Simply because I don't really want the pump to be running or doing really small pumps. But if here we go, I'm going to hit test and you can hear the relay clicking. Hang on. Fantastic. Okay, so again, ECU is controlling the fuel pump. It is priming it for however many seconds you want. I think it's 3.5 seconds. We've set it to a standard. Obviously, you can change that if you need it shorter, if you need it longer. But right, so that is everything in relation to the ignition on testing. Okay, so again, I've tried to go through as many things as I possibly can. I've used the CAN buttons. We've looked at the dash. We've gone through the cooling fans, etc., like that. So again, like I said, down below, I've got a load of videos about testing every other little thing as well. But anyway, that's all done now. I'm going to pop back. I'm going to get my ear defenders on and we'll do the test with the engine running. See you in a second. Right, guys, so I am back. I've got my ear defenders on because this JZ with no exhaust on is very, very loud. So what I'm going to do now is quick recap. Start a circuit. So we're going to use the button to start the engine. Then I'm going to kill the engine, start it back up again. Then we'll test the accelerator pedal to make sure that that is working with this particular setup. Then what I'm going to do is I'm going to unplug that pedal. I'm going to plug in that accelerator position sensor and I'm going to rev the engine as well, show you that both of them are working. And then we'll come back to the dash and we'll make sure that things like the coolant temperature and the tacho and everything are working as we expect them to. Okay, so as I said, from now, the CAN buttons are what is using the starting. So 3, 2, 1. Cool. And now I can kill the engine and start it back up again. Brilliant. Okay. Right, so accelerator pedal time. Let's give this a bit of a squeeze. Fantastic. Now I'm going to unplug this one. So you can see now that no longer works. Let's go ahead and plug this one in. Right, so that's the accelerator pedal. Now you can see on there we've got our tacho working on there. Okay. You can see we've got manifold pressure, we've got ignition angle, we've also got AFR on there because again I have that plugged in. You can see all of that data is matching up to that one over there. All pretty accurate over there, and obviously coolant and everything is working exactly as we expect it to. So we'll quickly kill the engine. Fantastic. Okay, guys. So, yeah, she runs smooth. Super happy with that. Both accelerator position sensors are working exactly as we expect them to. And obviously, all the data is coming through the dash exactly as we would expect as well. Okay, so that's everything for this harness. Hopefully, it's been fun to watch. I try to keep the videos shorter now because I know some of them are 45, 50 minutes long. But yeah, like I said, if you guys have any particular subjects that you'd like me to cover, please feel free to comment below, send us an email or whatever, and then I'll try and cover as many different, individual subjects as I can. I understand, obviously, watching a 40, 50-minute video to find one piece of information is tedious at the best of times. So again, thank you guys for watching. We got to get this all packed up. Customer's nearly ready to put it in his car and get everything running, and we'll help him with the rest of the process, like the dash, getting all the other bits wired up as well. But thanks for watching, guys. See you again soon. Bye-bye.
How it's supposed to feel.
Never break, always fight, never quit, do it right, play the game, win it life, have no shame, there's no time, feel the pain, live the grind, I could change, in my mind, pick a lane, commit and climb, the only way to win it life. I never miss, that's fact, taking big swings, each hand, you're the